This example 920, it says the National Institute of Standards and Technology provides exact data on conductivity properties of materials. Following our conductivity measurements for 11 randomly selected pieces of a particular type of glass. I've transposed the data here in Excel. Is there any convincing evidence that the average conductivity of this glass is greater than 1? Use a significance level of 0.05. We can assume the population is normal. We don't have the population standard deviation. We have a small sample, therefore we have to use a t-distribution in this hypothesis. And the hypothesis is pretty simple. It's, if we look at it, it's the probability that the conductivity is less than or equal to 1 because we want to show that it's greater than or equal to 1. So in this case, it would be easier to talk about the alternative hypothesis and say mu is greater than 1, which means the null hypothesis has to be less than or equal to 1. Now, I need to use descriptive statistics to get some data. So I go to data and I do data analysis and I go to descriptive statistics and I want to highlight my data here, 1.11 down to 95. The data's in columns, no labels in the first row. And I want my output to go, where do I want my output to go? Let's say I want to go right here. And I just want summary statistics. So I say OK. So here's my data. Here's the sample mean. So if I go home and make that yellow, and I want my sample standard deviation, and I'm probably going to make my standard deviation smaller, like maybe, let's say 3 decimal places. I want that bit of data. My count is on my n value, so I don't have to do that, sample size. Is 11. So very good. I need that data. What else do I need? I need my degrees of freedom, which is equal to 11 minus 1, which is 10. That's really important data. So I want to make that orange. And I forgot to make my standard deviation orange. Yellow, I'm sorry. I want my sample, so I know that to do this, this is going to be my statistic, is going to be t-statistic, and we're doing this on the sample mean. This is the standard deviation for the sample, so the standard deviation, let's call it standard deviation of the mean, is going to be what? Well, we have to divide it by, it's equal to the standard deviation, and not surprisingly, we're going to see another number up here that it looks like. We take the standard deviation right there, and we divide by the square root of the sample size. And it comes out 0.19. It came to the same number as this, the standard error. We already had it. So that's an orange number. And in fact, I'm going to make the mean also in this orange since it's the same number. There's other ways of getting the mean too. I could call this equal to the average of all this stuff, and it comes out to be, not surprising, all the same. And I could do standard deviation sample of all this stuff. And I get, if I take it down to 3 decimal places, it will be exactly the same. So, but I like to use descriptive statistics because it gives me the max, the min, it gives me the sample size, it counts all that. So I would leave it at that. Now, what is my test statistic? So I have a t statistic is equal to, and what I have is I have parentheses equal to parentheses the mean minus, we want it to be 1, so I'm going to take minus 1, and I'm going to divide it by what? The standard error, or the and that gives me a t-statistics of 2.014 if I take it down to 3 decimal places. Now I want to find the probability of t being greater than the t-statistic. That's what I want to find. So it's actually going to be 1 minus the CDF. Remember, the CDF is a right-tailed probability of the t-stat. Can't spell, but I'm okay. So I'm going to say it's equal to 1 minus, now I have t distribution, which if I double click on that, oops, sorry, oops, sorry about that, is a cumulative distribution of the t distribution. So I want not J22, but I want this 2.014, comma, what's my degrees of freedom? 10, comma, 1 for cumulative distribution, and I get this ridiculously long decimal place, which, let me take it down to 3 decimal places, is 35.036. This is my p-value. I'm just going to copy it over. It's my p-value. My alpha, or my significance, is 0.05. So I can make a conclusion, and I'll put it in a text box. Let's make it yellow again, I guess. I don't know why I'm using so many different colors. Maybe I'll put it in a box because it's important. My p-value is less than my alpha. So I can say, insert text box, as alpha is greater than the p-value, alpha equals 0.05, is greater than the p-value, we can reject HO and conclude that reconductivity is greater than 1. This is my conclusion. And that's basically how you solve a problem like this. So if I give this problem on the exam, I will give you the data, I will give you this, and I will, well, in fact, I'll let you use your computers to get on this problem, not on the first problem, but on the second problem. You can use data analysis. You know that the distribution of the mean will be this, and it will have a t-distribution. But you've got to calculate the t-statistic, the standard t-statistic. So it means you have to subtract it from this expected mean, which is equal to 1 in this case, or whatever. So you've got to establish your hypothesis, do your data analysis, and pick off the numbers that you need. You need the mean, you need the standard error, which is the standard deviation of the t-distribution of the mean, and the degrees of freedom, which is 1 less than the sample size. You do the, if you look at here, it's the mean minus 1 in this case, which is this number, parentheses, divided by the standard error, and that gives you your t-statistic. You got to decide which tail you're looking at. If it's a left tail, you don't have to subtract it from 1, you just get the CDF. If it's a right tail, you have to subtract it from that. In fact, if we want to draw the picture, we can put this picture up here. I don't know why it's, oh, I know why, because I have to do it this way. If I put the picture up here, you see my right tail, the probability is 359 or 036, and 0.05 is going to be here. So it's a rare event based on the preset significance that we looked at of 0.05. If we decide anything less than 0.05 is a rare event, and we can reject a null hypothesis, we have that evidence based on that decision criteria. All right, you can do this problem on the quiz using Excel. Thank you very much, and we'll see you in class